Hello, my name is Mikhail. I'm on the environments team. This video is a second video about GitLab AutoFlow. Um, the product idea for GitLab AutoFlow is to let the GitLab user automate tasks across the whole DevSecOps domain. And GitLab should be the platform at the center of that automation, allowing users to manipulate various domain objects and external systems via calling APIs. Technically, AutoFlow is a combination of three things. Temporal for durable execution, cloud events to trigger event handlers, and Starlark as a programming language to encode workflows. So user uses Starlark to build handlers for events that are durably executed on temporal, using temporal. Starlark is a subset of Python, so should be quite familiar to people. And of course, on top of this technology, we could build a user interface that encodes some rules or anything like that for the system to execute. So maybe we can have a non-code version of this. So I'm not going to go into lots of technical background in this video. Please watch the first video, which is a long version, and there I talk about all the technical details and implementation details. This video focuses on the proof of concept iteration 1, which is described here. So I have my GDK running. I have a modified version of CAS, Kubernetes Agent Server running. To be clear, this does not require Kubernetes, does not require any agents. This works fully just on GitLab, basically, plus the temporal server. So in this proof of concept, Natalia helpfully created the plan here. And in this proof of concept, we just try to achieve this, basically hard-coded configuration where some basic things are automated basically on the labels, plus we can assign, well, the workflow assigns the user in certain case. So this is what this proof of concept does. And the important difference here is how this is written and how it's implemented. So this is written in a kind of imperative style where a handler or an action is triggered when some transition happens for all four triggers. And but the code is written so this is called edge triggered when you have a change of state, and the handler is triggered when the state changes. So milestone is set. That means we add a label like this, right? And so on. This, like MR is opened or merged event, that event happens, and we take an action. And a different approach to this is to look at the state of the system, look at the state of an issue in this case, and related merge requests, and figure out what is the new state that we want this issue or MRs or whatever to be in. So based on the current state and the desired state, we make some changes, or we make no changes if everything is fine. And this is, for example, there are many pages on the internet that explain this, but this is one of the ones I like. So spec here is written in the age triggered style. So NMR is opened, that's the event when it happens. And then we take an action, or MR is merged, we take an action. And the approach the code is written in this particular case is that if there is an open MR, then the label should be there. Or if there are more than 0 MRs and they are all merged, then the other label should be there. So you see there is no transition, there is just state of the system. If there are MRs like this and that, state should be this. So it's a very different style, and this is how Kubernetes controllers work. And this actually is an article about Kubernetes controllers. And this style is way more robust and handles different edge cases much better. Like if an event is missed, it's still on the next event, we'll reevaluate the state of an issue, in this case, NMRs, and fix everything that's not according to the desired state that's encoded in the program. So let's look at the program. So I have this project in my GDK, AutoFlow PoC, and this is a file in like .gitlab flow.py. I use Py just because it gives me a nice syntax highlighting, and otherwise that's actually Starlark, but syntactically it's Python. It's evaluated from top to bottom, but unlike Python, you can't refer to yet undefined identifiers. So basically, program should be read from bottom up. So this refers to things defined before. So here we bind our handler, which is this function, to issue updated event, new issue, and because this is a proof of concept, we don't have any other relevant events right now, but we certainly can have other events that we bind to. So as you see, because it's level triggered, we call the same function no matter what event triggers state change. Or we would, if we had issue closed, we would also call it here, and so on. Like MR created, MR merged, they all would call the same function because it looks at the whole state and does whatever it needs to do. It doesn't care why it's triggered. It just looks at the state and changes things if any changes are necessary. So this one is, it's even called quite declaratively ensure correct issue labels. So I also made some tweaks here. Like if the issue is closed, we don't care. Like we just don't care about anything. I think that's logical. Anyway, here we just get the issue by the ID from the event, and we turn labels that are on the issue in a set, like mathematical set, and remove things. Well, we assume that these labels are all mutually exclusive, so we remove them all, and then we need to figure out which one to add, if anything. And then the same with assignees. This is IDs of the assignees on the issue. It's a set. This is defined right here. So it's just a set of the IDs of all the assignees. Then we get the related merge requests for this issue. And then this is main business logic, basically. If there are any MRs related to this issue and all of them are merged, this is basically we iterate and check the state. If all of them are merged, then we set label to verification, and then we add an assignee. And then if there are any open MRs with the reviewer, we set the in review and so on. If open but no reviewers, then it's just in progress. And if everything else kind of fails, then we check the milestone. So if the milestone is not unset, so set to something and it's not backlog, then we set the label to ready for dev. Then if we have a label to set, then we add it to the labels set. this one. And then we compare two sets, the one that is currently there to the one we want, and assignees as well. We compare assignees that we want to assignees that are on the issue. If they are both are the same as they were, then that means we don't need to make any changes. Otherwise, we edit the issue, which set the labels, set the assignees. This and like other get issue come from here, which is a lib is here, and it's a separate project. Separate project, so root flow library, libpy, and these are the helper functions that basically make the HTTP calls, call the API, parse, check the return status, check the content type, just on decode the response, and that's it. Or like edit is a put, and blah blah blah, passes the query parameters and so on. Just a library to work with the REST API. So this is the business logic is this basically. 30 lines of code and handler bindings in here. Okay, let's see how it works. So it lives in this project, so it applies to this project, and yeah, we can just test it. That's issue one, great issue. So to remind you, we only react to issue updated or issue closed, and updated is also triggered when an issue is created, I think. So if we set a milestone to something, then it sets the label. Now, because this is a declarative program, if we remove the label, it is ran again because we react on updated, and it looks at the milestone and the MRs, but there are no MRs, and it puts back the label. So we don't react to an event label removed. We just evaluate the whole thing, all the state in aggregate, and make changes if something needs to be changed. So yeah, and if we put it into backlog, or if we remove the milestone, it removes the label. So this part works. Okay, let's test, and it works really quickly, as you see. Let's create an MR. Open a separate tab. I wonder if I can do this from the editor. Sure, I have this checked out, this project, and let's create a branch test 5. I don't know. Let's just add a white space or and it's a branch test 5. We commit and push. This is the AutoFlow PoC repository. Push. Okay, then we can go and create the MR from this branch. And so because we don't have, this is a proof of concept, we don't have event for MR created or updated or closed or merged. This will not get any updates like right now. But if we trigger the handler like by editing something that does trigger an update, we like setting a milestone, it should look at the related MRs. But yeah, this MR is not related because I have not set the relationship. Okay. Again, we don't have an event for this, so we'll have to do something in the issue itself, like remove the label, and it relates. Now it sees the related MR, and now a different label is applied, as you see. And milestones don't matter anymore because they're in the lower if condition, and so we don't actually look. We of course can change this, but that's how it works right now. So in progress, we assign a reviewer, and it should change to in review. If we remove reviewer and any change to issue, yeah, you see it's not just label updates, any change triggers an update and reevaluation. Okay, if we assign and merge, so we have a merge request that is merged and all related MRs are merged. If we again trigger an update, this should be verification and it assigned a QA to the issue. And this is still not updated. We need to refresh the page. Okay, yeah. So this is proof of concept, iteration 1 done basically in a declarative style. That's all I have for the demo. Please watch the long version if you want to learn more about the technical details. Also, this demo doesn't show all the features that are already implemented in that proof of concept backend. Thank you.